Hello, hello, and welcome to this video. In this video, we will talk a bit more about tail recursion, which I left. I didn't have the information. The second thing which we are going to talk about are arrow functions, and finally, we will touch upon nested functions. So let's begin with tail call optimization. Let us take the case of all programming languages. Then most uh, functional languages do implement tail recursion. For example, in Erlang, Elixir, Lua, OCaml, Haskell, all have tail functions, tail call optimization. Then there are languages which implement via specific directives. If I remember, then Kotlin, Rust, and possibly Scala. I'm not sure about Scala, but Kotlin and Rust do implement tail recursion with special compiler directives. And I know about Rust. Rust in nightly feature prompts, there is a begin keyword which helps you with tail recursion. Then we have C++, which depends on the compilers. As far as I know, the GNU-C and Clang both do it. Microsoft VC++ or Visual Studio also does it. I'm not sure about how to do it in Microsoft Visual Studio, but in GCC and Clang, you can pass -o2 flag and it will do it. Then we have languages which simply choose to do tail recursion, tail call optimization. Those are Java and Python. Java has problems related to security when stack frames are overwritten, and Python developers say that the error messages are not proper because of the stack frame getting lost. In C++, unstable pointers can cause trouble with tail recursion. So you have to be careful about it in C++. But we will talk about JavaScript. In JavaScript, ECMA 2015 or ECMA 2.6 made it mandatory to implement tail recursion. Out of all major browsers, I have information about 3. Apple's Safari does it, but Chrome and Mozilla both refuse to do it. They say that debugging is very hard if tail recursion happens, and they just don't do it. So what you can say that if you want to be on safe side, don't use TCO. TCO is for tail call optimization. Don't use TCO in JavaScript. Again, I'm not sure about server side, whether it is done on server side or not. Node.js does it or not. But I think Node.js is based on V8 interpreter, which is essentially same as Safari. So I don't think Node.js will also do tail call optimization. So here is an example of tail call optimization, as I said in my last video. So this is the tail call, non-tail call optimized code. It cannot be optimized because the return value of this is in this. So it depends on this. Okay, this return depends on this function call. But if you look at tail factorial, this call does not depend on the next value, or rather next call, because we are computing the product and passing it along. Okay, so the product will go on increasing across the function calls and eventually get the final value. So that is why this tail call optimization is possible. For example, let's say n came with 5 and total 1. So then we are passing 4, 5. Now we don't need to come back to it. Then it will be 4 multiplied by 5, 20. That will become 3, 20. And then 2, 60. Then 1, 60. And then 0 will be reached and it will return the 60. So in this case, you see that there is no need to come back. Okay, you can go in one direction. That is essentially what tail call optimization is. You go in one direction across function calls, but we don't need to come back. But if you look at this function, then you first you go for 4, then 3, then 2, then 1. and then 0. So when 0 happens, it returns 1. Then you come back and you multiply 1 with the 1. Then you again come back, you multiply 1 with 2. Then you again come back, you multiply that with 3. So by come back mean this return will execute. Okay. So that is all about tail call optimization. It is personally, I find it very interesting. TCO is kind of very important. That is my personal bias of tail call optimization. I don't like that Safari or React interpreter of Chrome and Mozilla don't do it. It is a very nice feature. Now, the second thing which we are going to talk about are arrow functions. So arrow functions were introduced again in EC ECMAScript 2015 ES6. So they do not use their own this object. They have this pointer of the environment, and they do not create their own invocation context as normal functions. They also do not have prototype property, which means they cannot be constructive functions, which we will see in classes. Okay, both these we will see in classes. So there are kind of advantages of this, particularly when you want to pass arrow functions. Let's go through the syntax of arrow functions. So you can assign it to any variable because functions are first class objects in JavaScript. So we have argument list that's followed by arrow function, and then within braces you can write code. Okay. Now we can invoke this function here. For single statement, you don't need the braces. Okay. If there is single parameter, you don't even need the parenthesis around. But if there is no parameter, you need parenthesis. Okay. Now for returning object literals, you need parenthesis here. Okay. So this is fine. This is fine. Okay. You return either an object or here you return an object. This is problematic. Okay. This is problematic because it could be considered as a label statement, and you will see that H will be undefined here. And this version is even more problematic because it is syntax error here. Okay, let me show you. So it will cause syntax error. It will say that semicolon expected. This won't work. So when you are returning objects, make sure that you surround them by parentheses. Then the use of arrow function is one of the uses which is very common is using them in filter and map or even reduce. So in this line 43, we have an array 1, null, 2, 3, and we have a filter which has a predicate x not is equal to null. So if x is not equal to null, it will return, and our array will become 1, 2, 3. Otherwise, so it is a null filtering function. And then we have square calculation where we take parameter x and multiply with itself to get the square. So what you will get the array is 1, 4, 9, and 16. Now we come to nested functions. We have hypotenuse, and inside hypotenuse we have a square which takes one parameter and gives the squared value. So we use the square function in calculation of hypotenuse and we return it. Okay. So the advantage here, you can see that if you have lots of squaring to be done, you can simply call the function again and again. This code can be quite big, right? Here it is one line, but the code can be quite big. So if other places you don't need squaring or special function, you can put as a nested function. Otherwise, you can take it to the global scope. And we compute the hypotenuse and all. And finally, we see the run of this. So this would be node func2. And there we go. We have our values. So I'll let you verify this with the output. And so 38 was which one? This one was 38. Okay. So the important one is the output of this H and G. So this is H, this is G, okay, and this is F. This is the output of F. So X is undefined because we don't have any X, so X is becoming undefined. But the point is that we have the object in FNG, but in H we don't have the object, while our intention was to get the object. So with this, I will end this video here, and the important part in this video are the TCO optimization. That is, don't use tail call in JavaScript; it just won't work. Okay, make sure you are guaranteed that recursion depth is quite small, or in general, don't use recursive functions. It's just not worth it in JavaScript. Just make use of a stack and then write an iterative solution. I've said that I will show Ackermann function implementation, but I forgot to implement. So in the next video, I will show you the Ackermann function uh, trying to do tail call optimization. Okay, it won't work, but we'll see. I'll show you how a stack can be used to do tail Ackermann function. Then arrow function syntax is important, as well as these two properties are very important. So these two properties we will see when we discuss classes, which should be next topic, I believe. By next topic, I mean after functions. And nested functions is quite simple. So with this, I will end this video here, and I hope that you have received some useful information about tail calls and arrow functions. So thank you for watching the video, and we will meet again after 4 days with another video on JavaScript. Till then, enjoy and keep programming.